All right, so now we're at 2.2, basics of functions and their graphs, part 2. So this is basically just a continuation of the 2.1. And so what we're looking at here now, you can see we have our function notation. So right here it says use the graph of f meaning the function, to find each indicated function value. So just kind of reviewing function notation. This right here is the x value that's being given, and we're supposed to find the y value. So we want to find the y value for when x is 2. So you have to look where x is 2. So here's my x-axis, and I'm sorry, -2, and x is -2 right here, and so that point would line up right here with this value on the graph, this point right here. So when x is -2, the y value is -4, and so that's the answer. So f of -2 equals -4, and so that is my answer. So the prior video, we were actually plugging this into an equation and having to do some algebra to come out with the number. Okay, and so what we're doing now is we just have to look at this picture over here. So on this next one, it says f of 4. So once again, that's referring to the x value. So when x is 4, what is the y value? Well, let's see. When x is 4, it looks like y is also 4. So they happen to both be 4. So when x is 4, I get my result is 4. And then the last one, f of 3. So let's see, when it's 3, right here, when x is 3, the y value is 0. And so that is my answer right there. Okay, so I have one more of these where we're given a new graph G, but we're going to use the G graph to help us out here. So part A is really no different from what we were doing above. So G of -2 would be right here. So when x is -2, the y value is a 1. And then part B is actually going to we're going to go in reverse. They're asking us to find the x value for when g of x equals -1. So what you're going to notice a lot of times is that, remember, the function notation is just the same thing as y right there. See, y is equal to g of x. So right now what they're doing is they're telling you y equals -1, x equals what? That's what we're looking for now. They want us to find the x value. So now we're going to kind of go in reverse. We're going to look, okay, here's where y is -1 at this point. And so when x is 1, y is -1. So the answer to this one is a +1. Because this time, like I said, they gave us the y value, and you had to find its partner. And so in this case, the x value was a +1. Okay, this next part is going to be the bulk of the lesson. What we're going to do here is we're going to be given a graph, and we need to determine the domain. So if you remember, domain is just the list of x values, okay? The range is going to be the list of y values. And then if there are any x-intercepts, they want us to go ahead and list that. If there are any, I'm sorry, yeah, x-intercepts or y-intercepts. And then they want us to find the missing function value indicated by the question mark below the graph. So for example, on this one, they want us to figure out what is f of -3. So very similar to what we were just doing up above. So let's start with the domain. So domain, once again, that's just our x values. And so looking at this, you just need to focus on the x values. And so let's see, this x value would be -4, -2, I'm sorry, -3, -2, -1, 0, 1, and 2. So those are all my domain values. So I'm going to go ahead and list them. All right, so there are my domain values. Range values are going to be the y values. So let's see, I have a y value at 1, 2 of them are at 2, 2 of them are at 3, and 2 of them are at 4. But from previous lessons, we mentioned that you only need to list it once. So 1, 2, 3, 4. So even though there were 2 points that had a y value of 2, we just need to list it once, and so on. Okay, x-intercepts would just mean, do we touch the x-axis anywhere? And we don't have any, so none. Okay, y-intercept, do we touch the y-intercept anywhere? We do, right here. So that y-intercept would be at 0, 2. So that's it listed as an ordered pair. Also, sometimes if we have multiple intercepts, sometimes we just make a list and we use set notation, and we would just say my y-intercept is at 2. So either one of these notations is correct, but just be careful when you're doing your homework to read the directions and make sure it may say list as an ordered pair, or if you see those little squiggly lines, that might indicate that you're dealing with set notation instead. So just something to look out for. Then our last part is just, okay, what is f of negative 3? Well, they're telling you what x is. X is negative 3, and the y value that pairs up with negative 3 right here. So when x is negative 3, its partner y is positive 3. So f of negative 3 equals positive 3. Okay, so like I said, most of this lesson is actually going to be very similar to this question we did right here, but what I want to point out about this graph is this is known as a discrete graph. And what that means is that these ordered pairs, we can count how many there are, right? There's 1, 2, 3, 4, 5, 6, 7, and so on, right? So there's 7 points here. We're going to look at continuous graphs moving forward. And what that means is that we're going to have an infinite amount of points. And so in order to list the domain and range, we're going to have to use a different notation. So let's go ahead and jump to one of those. So right here, if you look at this, the most common mistake we'll see students do, let's see, negative 1, 2, 3, 4. So this is at negative 5 right here. And so they'll say, you know what, the domains, you know, negative 5, negative 4, negative 3, and so on, right? The problem is we're missing all the decimals, like negative 4.5 or negative 4.4 or negative 4.0441, right? There's actually an infinite amount of points that we could come up with on this line that's right here. Now, let me mention, you know, this is one of these topics that once you get it, you're like, oh, that's fairly simple, but sometimes it takes a couple examples to kind of click. And once it clicks, you're going to be fine. You'll be in, it'll give you no problems. But the first few examples, you might be thrown off a little bit. So we're just going to kind of take this slow. And so, as I said, we're going to have to use a different notation. We can't just list the points because there's an infinite amount of points. So if you remember from Unit 1, we used inequalities to represent infinite set of solutions, right? Well, that's kind of what we're going to do here. And so if you look at this, remember, just focus on the x values. Don't even worry that it's going down. Don't worry that it's, you know, it's sloping down. We're really just kind of concerned about from left to right when we're talking about domain here. And so what we have to do is, once again, come up with this notation. We're not actually, I know I said inequalities, but we're actually going to use interval notation. It's very similar. It's the same idea. And what we're doing is we're going to include negative 5, right? We're going to include negative 5. We're going to include negative 4, negative 3, negative 2, negative 1, 0. Uh-oh, we have an open circle here. So what that indicates is that we approach, but we do not include. So that's going to be a parentheses right there. And so that's a visual of what my uh, interval notation is going to be. So it's going to be from negative 5 comma 0 and then parentheses, because we are approaching 0 right here, my x value being 0, but we do not include it. And then as far as for my y values, that's going to be the range. You're going to kind of look from bottom to top. You want to start from the bottom and go to the top. And actually, I want to actually write that down right here. So we're going to start from the bottom, look from the bottom, and go to the top. And then domain, you actually want to look from left to right. And that'll make more sense as we do more of these, okay? And so I need to start with the lower value down here. So let me see, 1, 2, 3, 4. So this is at negative 5 right here, and it's not included, so it's going to be a parentheses. And then we go from negative 5 to negative 4, negative 3, negative 2, negative 1 up here. Okay, now I'm using the y-axis to kind of help me visualize this, okay? And so then I'm just going to shade this. So I'm kind of using this as a prop to kind of be like, okay, all the points on this blue line, all the y values are somewhere between -5 and -1. And so remember, you got to go from bottom to top. So the bottom goes first. So -5, which is not included, so I have to put a parentheses, then comma, all the way up to -1. And we do include that because we have the closed circle right there. Okay, so anyways, this is something that students can find helpful, is to use the X and Y axis to kind of visualize this. Sometimes students say, you crash it onto the axis. So you take this and just push it all the way to the axis right here. And you see it's covering from -5 to -1. And you could kind of think of this the same way with the X axis. You could have taken all these points and pushed them all up onto the X axis. And it just makes it a little bit easier to visualize it, to have that kind of almost like a number line here, and then transform it into interval notation on for your answer. Okay, x-intercepts, none, and y-intercepts actually none, because it's an open circle, so I don't actually touch the y-axis right there, so I don't have one there. And then my function notation, so f of -1 would be this point right here. And so when x is -1, it looks like y is -4. And so that's actually my answer. F of -1 equals -4. And so that is the answer to that. All right. So like I said, if you got it, great. If you don't, if you're not quite there yet, that's okay. We're going to do quite a few examples. And like I said, once you really understand it, or it kind of falls into place, you're going to be like, okay, yeah, I can do a bunch of these. Um, Okay, so looking at example C, once again, we kind of want to go from left to right, but if you look here, I know it's going down. It's hard to not kind of look at that, but it's also going to the left indefinitely, okay? And as it goes to the right, yes, I know it's going down, but it goes to the right indefinitely, okay? And so what that means is it's going this direction towards negative infinity, and it's going this direction towards positive infinity. And so if you were to follow this forever, there's no gap from left to right. Okay, if you look at this, there's no gap from left to right. And once again, you could crash it onto the x-axis. It's going to cover all these points from left to right indefinitely. Because like I said, this is going, I know it's going down really fast, but it's also going to continue to bow out to the left and to the right. So the domain on this one's actually from negative to positive infinity. It covers everything. Okay, now range. Remember, we want to start with how low to how high. So bottom to top. So the bottom, there really is no bottom. It goes down indefinitely either way. However you look at it, it's going to go down the y-axis indefinitely forever down to negative infinity. Now going up, that's a different story. We peak right up here at 4. We peak up here at 4. So my range is going to be from negative infinity to +4, and then I'm going to bracket that 4 in right there. Okay, x-intercepts, I actually do have two of those. I have two of those. I have one right here at -3 and one here at +1. So if you list them as ordered pairs, that'd be -3, 0, and at +1, 0. Or if you use set notation, you can just list -3, 1. The main thing is do not put parentheses around that if you're using set notation, because if you do, then all of a sudden you're talking about this point right here on the graph. That's the point -3 up 1. And so we don't want to do that. So just make sure if you're using this other notation, we don't want to put parentheses around that, because then all of a sudden we're talking about an ordered pair. Y-intercept right here up at 0, 3. Or if you're just using set notation, we just put a 3. And then my function notation, I want to know f of -2. So let's see, when x is -2, the y value, its partner, is going to be +3. And so that's what we're looking at here. Let's see, +3. All right, moving on. Here's another one. It's actually very similar. It's just this is an absolute value function. The other one was a parabola, but kind of it has the same behavior as far as the domain and range is concerned. So if you look at the domain, it's going up, but yes, it's going to go left and right indefinitely. So if you were to kind of crash it on the x-axis, it's going to go left and right indefinitely. So that domain is from negative to positive infinity. Now the range, remember from bottom to top, so the bottom of this is going to be at 1, and then it goes up indefinitely to positive infinity. So our range is going to be bracket 1 up to infinity. X-intercepts, none. And then y-intercept, I do have one right there at 1. So at 0, 1. And then our function notation, what is f of negative 1? Well, let's see, f of negative 1 is that purple point I just put right there. So its partner is going to be 2. So f of negative 1 is paired up with 2. Alrighty. So I got some more of these so we can get some more practice. So let's see, we have an open circle here, and then we kind of go up and down right here. But for domain, I'm just going to focus from left to right for a second. So this is the furthest left I go. This is the furthest right I go between negative 1 and positive 3. It's an open circle, so that means that this line, as I go over the top right here, I approach but don't actually get there. So that's going to be a parentheses. And then here, this point at 3, it actually, when x is 3 down here, it actually does include that point. So my domain's going to be from negative 1 to 3. Now the range on this one, let's see the range on this one. So remember, bottom to top, so I dip down at negative 5, and then if you follow this blue line up, it goes up, 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 all the way up to 4, and then it comes back down for a little bit, and I have an open circle there. So don't be thrown off by that. Yes, it's an open circle, but it's covered up over here, so that y value 3 is included. So we don't want to put a parentheses with a 3. We don't want to say that that's not included because it is over here. It's covered up over here. So this range is actually going to be from negative 5 all the way up to negative 4. And we're going to use brackets on both ends. So from negative 5 to positive 4. And then just be careful. You always want to put the smallest value first. That's why we go from bottom to top, and for domains from left to right. X-intercept, I have one right there at 2. So at 2, 0. And then my y-intercept is going to be at 0, 4. And then our function value, f of 1, I actually already have that highlighted up here. F of 1 is going to be paired up with 3 right there. All right. Here is another one. So let's see the domain from left to right. Let's see, I start at negative 1 and then I go to the right. If you follow the blue line, it goes to the right indefinitely to infinity. So I'm going to be bracket negative 1 all the way to infinity right there. Okay. Then for my range, I'm actually going to start here at 0, so be careful. It starts at 0, not negative 1. Sometimes students get a little thrown off because they see the negative 1, but that's referring to the x value. So the y value here is at negative 1. Then it goes to, I'm sorry, the y value is at 0. I just said exactly what I didn't want you to do. All right, so we start at 0, then we go to 1, then we go to 2, and then we keep going. We're going to go up to 3, and this line's going to keep going up, 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 and so those y values on this dotted red line keep going up, up, up to positive infinity. So my range is going to be bracket 0 to infinity. And then my x-intercept is at negative 1, 0. And my y-intercept right here is at 0, comma, positive 1. Then we're asked to find f of 3. So find the partner for when x is equal to 3. So when x is 3, y is 2. All right, so continuing on. So on this one, let's see, domain. Let's see, it's going down, but it's going to go to the left indefinitely. So we're going to go to the left indefinitely towards negative infinity. And then as I go to the right, it's going to go to the right indefinitely to positive infinity. So the domain is going to be from negative to positive infinity. And then let's look at the range. So the range is from bottom to top. Well, it goes down. It's going to go down indefinitely towards negative infinity. It's going to go up, and its highest point is going to be at negative 2 right there. So be careful. You want to put the negative infinity first, comma, negative 2, and then bracket that in. All right, x-intercept, none. Y-intercept, we've got it right there at 0, negative 2. And then our function value, f of negative 4. So let's see, when x is negative 4, let's see, the y value looks like it's at negative 5. So negative 5 would be that right there. Okay, one more slide to go. So I have one more of these, and then we're going to kind of switch gears a little bit. So let's start with domain. So let's see the domain. So that's an arrow right there pointing up and to the left. So it's going to go to the left indefinitely towards negative infinity. And then we go all the way over to 1, but we're approaching it. We don't actually include that point. We approach it. So it's going to be a parentheses right there. So the domain's going to be from negative infinity to positive 1, parentheses on both sides. All right, the range, this one's a little tricky here. So let's see, from bottom to top. So the bottom is definitely at negative 5. And then we go up, 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 up to 4. And don't worry about the 3. The 3's covered up over here. And so a lot of students think, okay, well, yeah, okay, it's from negative 5 all the way up to 4, right? Well, don't forget about this arrow over here. This arrow indicates that the graph's going to go up, up, up to the left indefinitely. So it's actually going to go up towards positive infinity. So this actually goes beyond this and goes up to positive infinity. So this range is actually bracket negative 5 all the way to positive infinity because of this right here. It's going to go past this little peak and keep going. And so you want to include those points. So that one was a little tricky. Okay, so x-intercept, that's going to make this one a little complicated because there is another x-intercept over here. Just don't worry about it because we don't know exactly where it's at. So let's just worry about this one. And so let's see, this x-intercept is going to be at negative 2, 0. And we do have a y-intercept, which is right here at 0, 4. And then our function value, f of negative 1. So f of negative 1, when x is negative 1, y is 3. Right there. Okay, so be patient with this stuff. If, like I said, once you get it, though, you're not going to have any issues. But until you get it, it can sometimes be a little frustrating. So, but if you have any issues, just let me know, and I'll try to clarify anything you need help on. But like I said, we're going to kind of switch gears a little bit here. We're going to go away from looking at the graphs and look at equations and talk about just domain here. We're not going to talk about range, just domain. So right here it says find the domain of each function. Remember, domain are possible x values. Hint, try to find the restricted values. So sometimes it's easier just to try to find the values that don't work. So we're going to look for values that make the function undefined or non-real. So dividing by 0 is undefined, and square rooting a negative value will result in non-real values. Okay, So really what you're kind of looking for is, do I have any fractions and do I have any square roots? Or you could be talking about other type of roots than square roots, but that's all we're going to really look at here. So if you look at the first one, um, I don't see any fractions or square roots. So basically, I can plug in whatever I want for x. Any positive, any negative number, I can plug in 0, whatever I want. So my domain for this is actually negative to positive infinity. There's no limitation on that. Now, if you look at example B, we do have a one value that cannot work. You can plug in anything you want except for this one value, and that one value is going to be -7. So what you technically want to do is, if you have a fraction, take the denominator, set it equal to 0, and solve. And so it's going to be -7. X cannot equal -7, because if you plug in -7 into the function, if you were to plug in f of -7, what happens is you'll get -7 divided by 0. Remember, we don't want to divide by 0. That's undefined. So what's going on here, if you look at this in terms of a number line, I'm just going to arbitrarily put -7 here. So we can't include -7, but you can include everything around it. So I'm going to put an open circle and then shade each direction. So you can put anything you want, just not -7. So everything approaching it. So like -6.999999, repeating forever. So you can get as close as you want, but you just can't get to -7. So the way we would write this domain here is it would go to the left indefinitely, so negative infinity all the way up to -7, but not including it. So I put a parentheses there, and then we use this notation. It's called the union, and so we do a little capital U here, union, from -7 all the way to positive infinity. So we're kind of like jumping over the -7. If you're kind of coming from left to right, we just come and we hop over it and then keep going. And so this domain, the only difference between this one and the first one was we just carved out the -7. It's just not part of the domain there. Okay, looking at example C, let's see, we've got x squared plus 4 times x minus 12. I don't see a fraction. I don't see a square root. You're fine. You can plug in whatever you want, and it shouldn't give you any issues. By the way, if you were to graph this, it's one of those parabola ones. It's the one that kind of has that bowl shape to it. And so it goes left and right indefinitely. So that's going to be from negative to positive infinity. Okay, looking at example D, it's actually kind of similar to example B. So you have a fraction, so something's going on here. So what you want to do is take the denominator, and well, since it's a quadratic, you want to go ahead and factor it to figure out what makes that equal 0, right? So I'm going to go ahead and do that real quick. So let's see, this should factor into x plus 6 and x minus 2. So that's what the denominator factors into, right? And so the two values that would cause your function to be undefined would be at x equals -6 or +2. Those are the values that if you plug into this function, if you plug that in for x, it's going to make your denominator equal 0, which then your function is undefined. All right, so once again, it might help to kind of make a little number line to kind of visualize this. And so I'm going to go ahead and let's see, we'll put -6 right here. We'll put +2 right here. And then what I'm going to do is I'm going to put open circles there because everything around it is fine, just not those particular numbers. So I can shade to the left indefinitely, shade between, everything between, and then everything after 2. So we just need to carve out those two numbers. So this first part of my number line right here, this would be from negative infinity to -6, okay? And then union, we want to get everything between -6 and 2, okay? And then union, and then we need everything beyond 2. So that'd be from 2 to infinity, and that is our domain for part D. Okay, E, we got a fraction, so you should kind of be a little concerned, okay? But I'm just going to kind of be upfront. This one's kind of a trick question, okay? Because if you try to factor this, you're not going to be able to, okay? So this is, now if it would have been x squared minus 9, that's different. You could factor that, but this is not the difference of two squares. It's the sum. So think about this. Is there any way that x squared plus 9 can equal 0? Using real numbers, okay? So I'm not talking about the complex numbers using like 3i or something like that. We're not dealing with those. We're not dealing with complex numbers. So if you're dealing with real numbers like 1, 2, 3, 4, 5, or -1, -2, anyways, any of those numbers, can this make this equal 0? And the answer is no. Because even if you plug in -3, you're going to get -3 squared is a positive 9. 9 plus 9 is 18. So essentially what's going on here, there aren't any real x values that will make my denominator equal 0. So I'm good on my domain. It's going to be everything from negative to positive infinity, okay? So that one was a little bit of a trick question, just kind of making sure we're thinking. Okay, these last two are square roots, and so what we're going to try to avoid here is square rooting negative numbers, because if we square root a negative number, that's when we get those i's. We get the imaginary solutions, the complex solutions. So it's pretty simple here. All you do is you take what's inside the radical, specifically the square root, and set that greater than or equal to 0, because you can square root 0. Square root 0 is fine, but what this is saying is you don't ever want to have an x value when you take away 4 that will make you negative. So this is saying this needs to be greater than or equal to 0 at all times. So go ahead and solve this. So we'll add 4 to both sides. And so basically, as long as x is greater than or equal to 4, I'm good to go. As long as I plug in 4 or something bigger, I'm good. And hopefully that kind of makes sense. Like, because if you plug in 3, there's a problem. 3 minus 4 is a -1. You just want to avoid negatives. So the last thing you have to do is convert this to interval notation. And so if you want to make a graph, you can, but I think at this point we're probably pretty good at just kind of taking an inequality and writing it in interval notation. So we want all values greater than or equal to 4. So from 4 to 5 to 6 to 7 to 8 to 9 and so on, infinity. So 4 and above will work. 4 and above, no problem. So that's my domain for that one. G, really, not much different. You're going to take this, 3x plus 8 needs to be greater than or equal to 0. And we'll go ahead and solve for x. And let's see, so then divide by 3 on both sides. So x needs to be greater than or equal to -3/8. And so pretty much going to do the same thing we did on part F. So greater than or equal to. So this is going to be the smallest value that's possible, and it is included. So -8/3, comma, and then going towards 0, and then all the positive numbers. So we use infinity to describe that behavior. And then we always use a parentheses with our infinity right there. All right. Once again, if you have any questions or concerns, make sure you send me an email.